Okay, so this is part 3. Does caffeine withdrawal lead to depression? And we're going to go back into confidence intervals now for mu sub diff. Diff stands for a difference. Your textbook, I think, just uses mu sub d. You may also see that. The D stands for difference. Okay. All right, so let's read the problem statement. It says researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. I could totally be one of these people. I drink so much coffee. So each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. Sounds terrible. So during one 2-day period, subjects took capsules containing their normal caffeine intake. And then during another 2-day period, they took placebo capsules. So remember that placebo means that it is going to look, taste, appear exactly the same as the caffeine tablet, but it won't actually have caffeine in it. And they won't know that it doesn't have caffeine in it, right? They're assuming that it's the same. So between these two-day periods, they wouldn't know which pill they're getting, and they probably don't even know that the placebo exists. So the order in which this subjects took caffeine and the placebo was randomized. So that's important for us because remember, these are volunteers. So we are not generalizing this to the whole population. It'll just be for people like those 11 volunteers. But they did randomize the treatments, so we can still make a conclusion about the treatments on those people. So at the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. Okay, so I'm already thinking, if this were a hypothesis test, I'm thinking that deprived of caffeine leads to an increase. So I'm thinking the test score for the first group for the caffeine pills is going, or I'm thinking it's going to be less than the test score for the non-caffeine group. That would mean that non-caffeine group is higher. So the table below contains data on the subject's scores on the depression test. Higher scores show more symptoms of depression. Okay, so here we are. We have subjects 1 through 11. And again, in column 1, we see, in the first row, we see just what the subjects are. So this first subject, those are both of his or her test scores, just for the different treatments that they received. So this is paired data. We are seeing 2 different test scores for one person. They are connected. These are the test scores for a first person. These are the test scores for a second person, or a 7th person, I should say. So this is definitely paired or matched data. Okay, so again, it says, construct and interpret a 90% confidence interval for the true mean difference in depression test score. And it tells me to do caffeine minus placebo. So I'm ready to write my parameter right away. I have mu1 minus mu2. It's a difference in the means. Oh, wait a second. It doesn't say difference in means. It says mean difference. This isn't mu1 minus mu2. Okay, be very careful. You have to read that carefully. I want to point that out one more time. Here I had, I'll go back to the very first page, a difference in true mean. And now I have a, oops, wrong page. And now I have a true mean difference. Okay, so that true mean difference tells us we're not doing mu1 minus mu2. We're doing mu sub diff. And although your textbook abbreviates to just D, I am going to go ahead and put DIFF because that really reminds me this is a difference. Mu sub diff is equal to that true mean difference in depression test score. And again, I'm doing caffeine minus the placebo. Okay, so my statistic then is something different entirely. And again, you will see this written a couple of different ways. The output for StatDisk, I think, just uses D, but you can also see X bar sub D. That's what we want. Okay, so now what is that? It's not given to us, is it? We just have the data. So after we type this data in, we will actually be able to find that difference there, okay? So let's do or at least write down the confidence level. We have a 90% confidence level. So we're gonna have to go to StatDist to figure that out. We'll come back to it. All right, so the name of our procedure. Now, instead of viewing this as two independent samples, we really have one sample here. We have the sample of 11 subjects. We just applied two different treatments to them. Okay, so this is called a one sample T interval for mu diff. Another way to think about this as one sample is that we could just go ahead, and the computer is going to do this for us. We could go ahead and write out all of the differences, okay? And just the differences would be the sample data that we are looking at. But we're gonna enter the data and it's gonna do it for us. Okay, so then we have to check the conditions. The first condition is the random condition. So we see that we have randomized order of treatments on the subjects. Again, we don't have a random sample, we have volunteers, but that randomization works. We think about the second condition. Oh wait, this is an experiment. We don't have a random sample. We don't have to check the second condition. So then the third condition is that normal condition. Again, there are 3 different ways to check it. We don't know anything about the population distribution, so the first way doesn't work. The second one would be that n is greater than or equal to 30, but n is only 11, so that doesn't work. Notice I'm gonna put out here n is equal to 11. So then we have to do the third way. We are hoping that the sample distribution will show no strong skew or outliers, but we will have to check that in StatDist. Okay, so the next video we'll be going to StatDist to look at all this.